Hello everyone. Welcome back to the course of Software Architecture and Design Patterns. This is our 7th video on SADP. This video is brought to you by Newton's Group of Institutions in association with Redefined Solutions. This is Aravind Yegireddy from the Department of Computer Science and Engineering, and in this video we will discuss about documenting software architecture. Now coming to uses of architectural documentation. Architectural documentation is both perspective and descriptive. That is, for some audience, it is perspective. That is what should be true for placing constraints on decisions to be made. And for other audience, it describes what is true by recounting decisions already made about the system design. All of this tells us the different stakeholders for the documentation have different needs, different kinds of information, different levels of information, and different treatments of information. So one of the most fundamental rule for technical documentation in general and software architectural documentation in particular is to write from the point of view of the reader. So here documentation that was easy to write but it is not easy to read will not be used, and easy to read is in the eyes of the beholder, or in this case the stakeholder. So here documentation facilitates the communication. Some examples of architectural stakeholders and the information they might expect to. So in addition, each stakeholders come into two vertices, seasoned and new. A new stakeholder will want the information similar in content to what his seasoned counterpart wants, but in smaller and more introductory doses. So here architectural documentation is a key means for educating people who need an overview, new developers, funding sponsors, visitors to the project, and so forth. Now coming to the views, here the concept of view, which we can think of as a capturing a structure, provides us with the basic principle of documenting software architecture. So here documenting an architecture is a matter of documenting the relevant views and then adding documentation that applies to more than one view. Here, this principle is useful because it breaks the problem of architecture documentation into more traceable parts, which provides the structure for the remainder of this chapter. That is, choosing the relevant views, documenting the views, and documenting information that applies to more than one view. Now coming to the first one, that is choosing the relevant views. So a very simple representation which represents a set of system elements and relationship among them. So whatever the elements and relationship we deem useful to a segment of the stakeholder community constitutes of a valid view. So here it is the simple three-step procedure for choosing the views for our project. Produce a candidate view list. So here this is the first one. So here begin by building the stakeholders view table. So you can see the stakeholders view table side. So here our stakeholder list is likely to be different from one in the table as shown. So but be as comprehensive as you can. So for the columns, we enumerate the views that apply to our system, and some views apply to every system, while others only apply to systems designed that way. So once we have rows and columns defined, we need to fill in each cell to describe how much information the stakeholders require from the view. None, overview only, or moderate details, or high details. Now coming to the second one, that is combined view. So the combined view is nothing but it is list from the step 1 which is likely to yield an impartially large number of views. So it is used to reduce the list to a manageable size. First look for the view is a table that requires only overview depth or that serves very few stakeholders. See if the stakeholder could be equally well served by another view having a stronger consistency. Next, we need to look for the views that are good candidates to the combined. That is, a view that gives information from the two or more views at once. For small and medium projects, the implementation view is often easily overlaid with the module decomposition view. So the module decomposition view also pairs well with the users or layered views. So finally, the development view usually combines with whatever components and connectors view show the component that are allocated to hardware elements. Now third one is prioritize. So here after step 2, we should have an appropriate set of views to serve our stakeholder community. At this point, we need to decide what to do first. How we decide depends on the details specific project. But remember that we don't have to complete one view before starting another. So people can take more progress with overview level information. So a breadth first approach is often the best approach. Now coming to documenting a view. So here primary presentation elements and their relationships contain many information about these systems, usually graphical or tabular. Element catalog, details of those elements and relationships in the picture. Context diagram, how the system relates to its environment. Variability guide. So here how to exercise any variation points a variable guide should include. Documentation about each point of variation in the architecture, including the operations among whose choice is to be made, the binding time of the option, and some choices are made at the design time and some at the build time and others at the runtime. And the next is architectural background, why the design reflects the view that came to be, and an architectural background includes rationally explaining why the decisions reflect in the view are made and why the alternatives were rejected, and analysis results which justify the design or explain what would have to change in the phase of modification, assumptions reflected in the design. Next, glossary of terms which is used in the views with a brief description of each. Next, other information which includes management information such as authorship, configuration, control data, and change histories. Or the architects might record references to the specific sections of the requirement documented to establish the traceability. Now coming to documenting behavior. So here views present the structural information about the system. However, the structural information is not sufficient to allow the responses about some system properties. Behavior description adds information that reveals the ordering of interactions among the elements, opportunities for concurrency, and time dependency of interactions. So here the behavior can be documented either about the group of elements working in concrete, or exactly what to model will depend on the type of the system being designed. So different modeling techniques and notations are used depending on the type of the analysis to be performed. In UML, sequence diagram and state charts are the example of behavioral descriptions. So these notations are widely used here. Now, coming to the documenting interfaces. So an interface is a boundary across which two dependent entities meet and interact or communicate with each other. In the first, we need to interface identify. So when an element has multiple interfaces, we need to identify the individual interface to distinguish them. This usually means naming them, or we may also need to provide a version number. Second one is resource provided. So this is the heart of an interface documented in the resource that eliminates that the element provides. So here we provide resource syntax, that is the resource signature. We provide resource semantics, and we provide resource usage restrictions. In the third, data type definitions. So if we used in any interface resource employs a data type other than one provided by the underlying programming language, the architect needs to communicate the definition of that particular type. If it is defined by another element, then reference to the definition in the elements documentation is sufficient. Fourth one is expectation definitions. So here these describe the expectations that can be raised by the resource of the interface. Since the same expectation may be raised by more than one resource, if it is convenient to simply list each resource expectations but define them in a directory collected separately. And coming to the fifth one, that is variability provided by an interface. So here we need to see, does the interface allows the elements to be configured in some way. So these configuration parameters and how they affect the semantics of the interface must be documented. Sixth one is quality attribute characteristics. So here the architect needs to document what quality attribute characters such as performance or reliability the interface makes known to the elements use. Now, seventh one is element requirements. Here what the elements require may be specific, named resource provided by the elements. So here the documentation obligation is the same as the resource provided, like syntax, semantics, and usage restrictions. Eighth one is rational and design issues. Why these choices? The architect should record the reasons for the elements interface design. So here the rationale should explain the motivation behind the design constraints and compromises, what alternative designs were considered. Next, coming to the ninth one, usage guide. So here item 2 and item 7 document an element semantic information as per the resource basis. This sometimes falls short of what is needed. So in some cases, semantics needed to be reasoned about the item of how the broad number of individual interactions interrelate. So these 9 are the part of the interface documentation which are shown in this particular form. So here we have first one, interface identity. Second, we have resource provided. Third, we have interface identity. Fourth, expectation documentation, validity provided, quality attribute characters, element requirements, rational and design issues, and ninth one is usage guide. Now, coming to the documentation across the view, cross-view documentation consists of just 3 major aspects which we can summarize as how, what, and why. So how the document is organized, we show it by using view catalogs and view templates. What the architecture is, that is what is system view, what is mapping between view, what is list of elements and where they appear, what is project glass ready. Why the architecture is the why it is. So why it is rational. So here coming to how to document, how the documentation is organized to survey stakeholder. So every suite of architecture documentation needs an introductory piece to explain its organization to a trainee stakeholder and to help that stakeholder access the information he or she is most interested in. So here there are two kinds of how information. One is view catalog. So here a view catalog is the reader's introduction to the view that the architect has chosen to included in the suite of documentation. There is one entity in the view catalog for each view given in the documentation suite. So here each entry should give the following: the name of the view and what style it instantiates, and the decision of the viewer's element type, relation types and properties, the description of what the view is for management information about the view document, such as the latest version, the location of the view document and the owner of the view document. Coming to the second one, that is a view template. So here the view template is the standard organization for a view. It helps a reader navigate quality to a section of interest, and it helps a writer organize the information and establish criteria for knowing how much work is left to do. Now coming to what the architecture is. This session provides information about the system whose architecture is being documented and the relation of the views to each other and the index of the architecture elements. Coming to the system overview, this is short prose description of what the system functions is, who is users are, and any important background or constraints. So the intent is to provide the readers with a consistent mental model of the system and its purpose. Sometimes the project at large will have a system overview, in which case this session of the architecture documentation simply points to that. And second is mapping between the views. Since all of the views of an architecture describes the same system, it stands to reason that any two views will have much in common. This helps a reader of the documentation to understand the relationship among the views and will give him a powerful insight into how the architecture works as a unified conceptual whole. So being clear about the relationship by providing the mapping between the views is the key to increase the understanding and decrease the confusion. Now the third one is element list. The element list is simply an index of all the elements that appear in any of the views along with the pointers to which each one is defined. This will help stakeholders look up items of interest quickly. And the fourth one is project glossary. So the glossary list and define terms unique to the system that have a special meaning. A list of acronyms and the meaning of each will also appreciated by the stakeholders. If any appropriate glossary already exists, a pointer to it will suffice here. Now coming to why the architecture is the way it is rational. So here cross-view rationally explains how the overall architecture is to face a solution to its requirement. So one might use the rationally to explain the implications of the system-wide design choice on meeting the requirements or satisfying constraints, the effect on the architecture when adding a foreseen new requirements or changing an existing one, the constraints on the developers in implementing a solution, decision alternatives that were rejected. So in general, the rationally explains why a decision was made and what the implications are in changed it. So that's all for now. Thank you all. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you one and all.